This week on The Agent Factory.
Ready to talk about memory with agents.
Oh my god, I feel like I need to free up some space in my brain just to keep track of all of those information.
We have a very special guest today. Hey Annie, did it happen to you to spend an entire week building an AI agent and then you feel like it has the memory of a goldfish?
Oh my god, you can't believe how frustrating it is even. It is one of the biggest challenge in context engineering. There's a huge gap of an agent can process information to actually remember and learn from it. It is so annoying.
Yeah, and that's exactly the gap we want to close today. Welcome to The Agent Factory, the podcast where we talk about the world of AI agents. I'm Nardini.
Hi, I'm Annie Wang. So today we're going to talk about this important topic of memory. And by the end of this episode, you will have a very deep understanding of not just the problem itself, but also a powerful solution that is Vertex AI Memory Bank. This is a managed service to help you build your own smarter and personalized agent.
As always, if you are enjoying our content that you think is relevant for others, don't forget to subscribe to your streaming platforms and activate notifications. So you will always keep posted about new episodes, and yes, you can share with others.
All right. So before we jump into agent memory, I want to share with you some of the latest and greatest update in the world of agent in this new agent industry path.
Yeah, a lot is happening. On the model front, we are just seeing so many releases from teams like Wang, and Google just introduced a Gemini DeepThink in Gemini Ultra. But you know what really excites me is the evaluation. And LangChain just released a line Evals within LangSmith to help developers making their automated evaluation better match with the human preference.
Yes, I saw that. So you can take your evaluator in a playground and see in real time how the scores compare to human labels, so that you better understanding the LM thinks a good answer versus human feels like a good answer.
Yeah, exactly. And speaking about specialized model, what's the latest?
Oh, talking about the model, this Chinese startup, Zhipu AI, they just open sourced GLM 4.5. This is a large language model designed specifically with agent in mind.
Yeah, I was reading the paper and they also have these, thinking mode capabilities, but this is not something new. Like Quant models, they already introduced it.
Yes, but when it comes to performance, they're doing so well. GLM 4.5 ranked third, and GLM 4.5 Air ranks 6 on the suite of 12 benchmark focused on reasoning, coding, and agentic tasks.
Okay, so how were they able to get these results?
Okay, let me tell you. Under the hood, the model was pre-trained on massive 15 trillion tokens of general data, followed by 7 trillion tokens focused on code and reasoning, and then it goes through additional fine-tuning on instructional and domain-specific data set. Not only that, there's a cool part. The GLM goes through reinforcement learning post-training. So this step is significantly increased agent-like capability, including using tools, performing deep web search, and even real-world coding tasks. So if you want to building something cool, check this. Don't forget to check out this model.
Yeah, no, it sounds pretty exciting, but it's not just about models. Let's talk about the agent framework that are moving so fast right now. And in particular, Agent Development Kit and the agent-to-agent protocol are just on fire. And the latest ADK release introduced this new concept of plugins.
Oh, this is a pretty cool feature. So when building agent, you often end up writing repetitive boilerplate code for things like logging, authentication, and caching, especially in the global level.
And with this new plugin class, now you can set function from logging and caching and the other capabilities at the global level. So you don't have to manually set them for every single agent, models, and tool in your entire system. So it's the kind of set it once and use it everywhere pattern that will make agent development so much cleaner.
Yes, and also on A2A side, version 0.3 just dropped with a more stable Python SDK, gRPC support, and also enhanced security.
Yeah, these are very relevant capabilities, features that makes the protocol even more flexible, more secure, and easy to integrate with your existing agentic systems.
Oh my god, I feel like I need to free up some space in my brain just to keep track of all of those information. I really need some memory.
Yeah, in fact, actually memory is the right words to jump in the factory floor. Ready to talk about memory with agents.
All right, let's start with the basic even. Why it's so important to have memory?
Yeah, to give an idea, Annie, why it's important, let me quickly show you a demo where I compare an agent with and without memory. So in this demo, we have a very simple comparison UI. So you have an agent with memory and an agent without memory. And so we can start interacting with these agents. So in this case, I just say, hey, I'm Ivan, I'm a developer advocate. And let's see the response. As you can see, like it's pretty generic. And then I will just give the agent some information, like I love cats and I like learning new things. So again, the response that the agent will generate should not surprise us. It may be longer, it may be shorter, but nothing new. So now let's assume that we start a new conversation with these agents. And let's just type hello, just to see if the agent is still working. If you see, like the agent without memory generates, again, a generic response, but the agent with memory, it generates a personalized response where he mentioned about cats, and maybe he asked me about if I want to learn new things. So that's how powerful it is having an agent with memory.
Cool. I love the demo. From the demo, I can tell that memory really make a huge difference for user interacting with agent. So without a memory, this agent feels like a digital goldfish. It doesn't know what's going on. How did you build this demo with, like, especially the one with memory? Like as a developer, if I want to build something like that, how do I get started?
Yeah, these are all great questions, but before to answer them, I think we need to break it down. So to understand memory in AI agent, we first need to understand the difference between different type of memories, as well as the difference between concepts like sessions and memory, and why building and managing them in agents can be complex. But in order to do that, like we can use agent development kits and the new Vertex AI Memory Bank on Agent Engine, which is a memory. It's a managed service that provides long-term memory to our agent, so you can personalize them. It makes things like a lot more easier.
Yeah, sounds like a good plan. But before we jump into detail, a quick reminder that all the results we cover today will be available in our show notes below, so you can review them later on.
Cool. All right, so let's start with the goldfish challenge that you brought it up.
By the way, I just found out the goldfish has pretty good memory.
Okay. Anyway, in general, with a typical agent, every turn is a new start. So imagine that you have this agent and you say, hey, my name is Annie and I want to know the weather in San Francisco. So the agent will use the reasoning loop with the LLMs and tools and generate the response. But now let's assume you just ask, what's my name? The agent probably it doesn't have memory of the previous interaction because the context is gone, and it will respond something like, I'm sorry, I don't know your name.
Oh, I see. So we need a way to keep this information so agent can remember user's name in this conversation, right?
Exactly. So what you need is a way to build what is called working memory or short-term memory for your agent. And in order to do that, we need to introduce this concept of session. So with session, you can keep this information that is, you are having during the conversation with your agent and pass it within the LLM context window. So now when the user asks, what's my name? The agent see that information in the session history, in the context, and then can generate the response or can answer correctly.
Wow, that is cool. So it is great that with the session, now it can remember my name. And this makes sense for a single conversation. However, I can already see a lot of problems. So first of all, the context windows are finite. As a long conversation continues, you're stuffing with more and more tokens, which costs more and slows things down, and can eventually introduce noise that hurts the quality of the response, right?
Yeah, that's just one problem. Like another problem is that as soon as you start a new conversation, again, the session is empty. And so the agent is back to being a digital goldfish.
Yeah, so this actually brings us to an additional problem we need to solve.
Correct. So as before, like right now you need a way not only to store, but also process and retrieve the relevant information across multiple sessions only when it's needed.
Okay, so I get it. We need something more persistent. We need an agent to learn from our conversation, not only just to repeat them, but also you need extract key facts like Annie is a developer, Annie is planning a trip to store them for the long term.
Yeah, correct. And that's what do you need is actually a long-term memory that will allows you to do that. So it will allows you to store, process, and retrieve relevant information across multiple sessions and inject them in the context only when is actually needed.
Yeah, but building that from scratch sounds like a lot of engineering work. You need a system first to extract facts and then consolidate them, and then handle the contradiction, and then have a complex retrieval system on top of it.
Yeah, exactly. And that's why we decided to introduce Vertex AI Memory Bank on Agent Engine. So a managed service that does all this heavy lifting for you. So it agentically extracts facts, deduplicate them, updates them when new information comes in, and provides this simple retrieval mechanism.
Oh, I wonder, how do you integrate memory bank with agent? For example, assume I have an ADK agent.
Yeah, actually, it's pretty simple. Like we provide, ADK provides a tool, the preload memory tool, which automatically retrieve relevant memories to the start of each turn and inject them in the agent system instructions. And then you initiate the memory bank, the session services, and the ADK runner to orchestrate all of them. So the agent, it will be capable of interacting with the memory and generate a response for the user.
I like this example with ADK. But how about I'm using different agent framework like LangGraph, Crude AI, Pedantic AI?
Yeah, of course. I mean, this is just an example. Vertex AI Memory Banks provide an open API that you can use to integrate memory with LangGraph, Crude AI agents, or the framework that you are using.
But you know what, even it seems like memory bank is a different application of retrieval, augmented generation, RAG in shots. What is the real difference between them?
Yeah, no, that's a great question. And to help us answer it, we have a very special guest today.
Yeah, our guest today is a core contributor for Vertex AI Memory Bank on Agent Engine. Please welcome Kimberly Milam, the tech lead for Memory Bank.
Hi, everyone.
Hi, Kimberly. How are you today? How do you feel?
It's great. It's great working on Memory Bank. It's such a fast-moving area, and it's exciting to bring personalization to agents.
That's so cool.
Yeah, we were just talking about Memory Bank. I wonder, what is the real benefit of using Memory Bank versus other DBs?
Yeah, so normally when you're using a database, it's pretty static. So your API, your agent is making direct read or write requests to your database. And generally, you write exactly what's in the payload. You write that information directly to the database, and the database itself doesn't really manipulate that information. On the other hand, with memory systems, we take the information that the client provides and extract only the most meaningful information, so that we only persist information that would be helpful for future conversations. So it's a much condensed version of the information that the client might provide to us.
That is really cool. How about RAG? What is the real difference between Memory Bank and RAG?
Yeah, so this is definitely a common question that we get. There's a couple of differences, but one of the ones I'll focus on is just the usage patterns for RAG versus memory. So with RAG, generally an external developer is responsible for uploading the information to the corpus of information. So a lot of times this is external knowledge, maybe specific to your company, so like tutorials or just internal documents. But the key thing is it's managed externally from the agent, and it's external knowledge. On the other hand, you can think of memory as more internal knowledge and information that's more scoped to a particular individual or class of users. Also, the usage pattern with memory is generally that the agent is both reading and writing information. So it's a lot more dynamic. So basically, when the agent is working or conversing with the user, there will be generation requests, which will result in new information being written to the memory bank. And then I'll also be reading memories that already exist for that user and including it in the prompt and conversation. So it's a lot more dynamic than RAG, where it's kind of managed externally to the agent, whereas within a memory bank or other memory products, the memories are kind of managed based off of the conversation and execution of the agent.
I see. And just because we are touching the process, can you give us more details about how the process of memory works? Like, how do you generate memories and how you consolidate them?
Yeah, so there's two main processes. The first is memory extraction, and the second is memory consolidation. With memory extraction, we take that super long conversation and we extract only what's meaningful from that conversation. Of course, this is using an LLM. So we've predefined topics. So that includes user preferences, whether that's explicit or implicit, information about the user, key conversation events or like milestones within the conversation, and then also explicit instructions that the user might provide to remember or forget information. So the LLM will inspect that conversation, see if there's information relevant to those topics within it, and then extract that information.
I see.
But like conversations with the user could be pretty duplicative. It could cover the same information or even like slightly different pieces of the conversation. Like for instance, maybe I introduce myself multiple times and I don't want a ton of memories that are like, my name's Kim, my name's Kim, my name's Kim. That's not actionable in reality. You really just want to include each distinct piece of information once. You also don't want to make sure that you don't have pieces of information that contradict each other. Like my favorite animal is cats, my favorite animal is dogs. You want like one true source of truth. So the next process after memory extraction is memory consolidation, where we analyze the existing contents of the memory bank for that particular user and use an LLM to identify whether new memories should be added, existing memories should be updated or deleted if, say, the information is now completely outdated.
It seems like a very complex, multi-step process to engineer. Are we using Gemini to do that?
Yes, we are using Gemini. And with respect to the complexity of the algorithm, one great thing is you as a developer don't even have to think about that because it's kind of automated under the hood for you. And you just have to think about like building the best agent that you can, providing your conversations and somewhat trusting memory bank to extract and consolidate the memories for you. That being said, if you do want more control over your memories and, for instance, use memory as a tool where your agent's responsible for extracting information, you can send us those memories. And then what we'll do is we'll perform consolidation so that we combine those new memories that you provide with existing memories we already have, doing that whole dedupe process so that you can, again, have that more fine-grained control, but we will still do the consolidation for you, so giving you more control.
Okay.
Yeah, it is so cool that it is automated and developers don't have to worry about it. However, if I'm a user using memory bank, I do want to manually control it. Like do I need to like keep all the conversation history in the memory, or do I need to delete or update them from time to time? What's the best way to manage them if I really want to manually control them?
Yeah, so one key distinction there is that memory and sessions are different things. So sessions, which we manage your product called Agent Engine Sessions, but you might have your own database to store sessions, are generally the turn-by-turn conversation history. So it's kind of like an immutable log of everything that's happened in the conversation, turn by turn, very explicit. Memories, on the other hand, are more extracted information, more condensed, more self-contained. So slight distinction there. In terms of management, in an ideal world, Memory Bank would do all of that management for you. So through the consolidation feature that I was mentioning before, we will automatically update or delete memories that we have like contradictory or slightly different information on in the conversation. So that should hopefully be automated for you so that you as a developer don't have to think about it.
Yeah.
That being said, a lot of times developers do want to think about these things. And so for that, you can always use like the CRUD APIs to directly manipulate the contents of Memory Bank.
Cool.
No, that's a very good point. And so if I can manipulate the content, so I can get access to essentially the memories that are generated. And on the other side, I have also sessions, right, that you mentioned. Potentially, I can build some evaluation process that allows me to understand how good are the memories that got extracted from sessions. So my question is, how do we can we put this evaluation process in place? How evaluating memory works?
Yeah, so evaluation is definitely a tricky topic, and in my opinion, not a fully answered topic, especially if you consider the differences between academic data sets and kind of the things that you care more about in production. So for instance, the academic data sets, which don't include tool calls, which are so key for agents, in some ways, you can reward the wrong behavior of your memory system, because if you're just storing all of your memories and kind of including an explicit log of everything and not being very like careful about what information you're saving, you'll have great performance because you have that explicit log of the conversation and you're not really being discerning in what information you're saving. But in a production system, you don't necessarily want the latency of including everything. You don't want the data volume of saving everything. And then also from a privacy standpoint, it gets to be a bit tougher. So in my mind, evaluation is still an open topic that we're working towards. That being said, you of course can define your own golden data set of like cross-session conversations where you expect memory to help. So maybe it's a conversation where information in the first session, you expect it to help answer the questions in the second session without the user ever having to explicitly provide that information. So I'd say right now the best way to do is to provide your own data set that extends across multiple sessions and then testing memory bank to see if it really helps with that cross-session continuity.
Yeah, no, it's great to know that, evaluation, it's still an open topic. So there is some space to do research, and maybe for people that are interested, they can just look for a solution.
Yeah, you just talk about production. I wonder in production, how efficient is the overall mechanism? Like, for example, is a fetching latency has to do with how much memory I have? Is that big O of n, big O of log n runtime?
Yeah, so my general philosophy is to do the hard work where you're not latency sensitive.
Okay.
So generate memory should generally happen in the background where your agent or user isn't waiting for the memories to be extracted. So you have some time to do like the best extraction that you can there and to like get the highest quality memories. On the other hand, on the retrieval side, the user is generally waiting for a response. So you really don't want the like latency intensive operations there.
Yeah.
So going back to my point, like you want to make sure that the memories that you're extracting are of the highest quality so that like your base memories perform well rather than needing to put so much pressure on retrieving only the best memories. So you really want to be you don't want to extract too many memories, essentially. Yeah. That being said, we have two different retrieval methods. The first is retrieving all memories for a particular scope. So you can think of scope as a like arbitrary dictionary that defines like a class of memories for a particular identity. Okay. So for example, I could have a scope that's user ID equals Kim, and then all of the memories for me would be included under that scope. And so if I'm retrieving all the memories under that scope.
I see.
I can also use similarity search to retrieve only the most relevant memories to some search query. But that, of course, you would incur the latency from the embedding API, of course, and the actual similarity search retrieval.
Yeah, so depending on essentially the use case or the way you design the system, you might use one method or another.
Exactly. I'd say the key thing is just being very limited in like the types of memories that are created and only creating memories for the most helpful pieces of information so that you take less stress off the retrieval because the average memory is a good memory.
No, I get the point. And actually, like again, this aspect of flexibility of memory bank is so exciting. And talking about how flexible it is, like memory bank is part of Vertex AI Agent Engine, which is this platform on Vertex AI which allows people to serve and scale, agents. But as a user, maybe I'm just interested not to use all the platform, but just memory bank. So how flexible, again, memory bank is to be integrated in my own, agent development journey?
Yeah, so this is a very common question we get. You might be more familiar with Agent Engine Runtime, where basically you take your code and your agent and then deploy it to like a remote execution environment, Agent Engine Runtime. That's one of the subproducts under Agent Engine. Other subproducts would include like sessions and memory bank and so on. So you can mix and match the subproducts under Agent Engine. Of course, the happy path is always using them all together, but you don't have to. You could take your memory bank and use it in GKE, in Cloud Run, in Colab, and it's very easy. And let's say later on you want to take that same memory bank instance and use it in Agent Engine Runtime, you can do that as well.
I see.
And it just takes like a couple of seconds to get started since you're not deploying any code to Agent Engine Runtime. So it's very easy to just get started and use it in your collab.
So just to clarify, like if I have an agent, I don't know, in a LangGraph or Crew AI, I can simply plug in a memory bank as a memory service.
Yeah, definitely. You would basically just take the standard memory bank APIs, wrap it in a tool, and you're set.
That's cool.
Yeah, that is so cool. I feel like we're ready to go and just build some agent right away. But just to wrap up, thank you so much, Kimberly, to be here. And we learned so much.
Yeah.
My pleasure.
Yeah, it was such a great session. And I think we covered everything. So we explained how Memory Bank works and how people can use it. So I'm pretty excited to see what they're going to do.
Awesome. And let me know if you have any questions.
Yeah, that's a good point. That's a good point. We'll share with you the question after this session.
Yeah.
Thank you again. All right, so it's time to answer some of the questions from the community. First up, Daniel Clayton 1125 asks about the official online community for ADK. Now, this is a great question, and I think there are two main hubs to consider: the GitHub discussion for feature requests and deep conversation with the engineering team, and then the R agent development kit subreddit for broader community support from Googlers and other developers. So we can share the notes in the description below.
Cool. And the next one is from Google Forum. We have Clarence want to know how to make an ADK agent act deterministically, basically for example, using simple if and then logic to route requests to other agent. So we have Mercado 97 reply to this question. But to better understand Mercado 97's solution, first you need to understand the agent lifecycle and how to intercept them with callback. So specifically, the before model callback. This let you intercept agent's actions right before it calls the LLM, and you can implement your routing logic there and return a predefined LLM response. So there, agent will use this LLM response instead of calling the model. It gives you the full control over the agent flow, and here is an example of Mercado 97 shared.
Perfect. And our last question is more about building collaborative agents. So a developer asks, how can we make a Vertex AI Memory Bank shared across a team rather than being limited to a single user?
Yeah, this is where scope-based retrieval becomes so powerful. So when memory is created, you can attach a scope to it, which is a dictionary of metadata. It's like a team ID or department ID.
Yeah, so when one member's interaction generates a useful memory, it gets saved just in that scope. And then later, when a different team member interacts with the agent, you can configure the agent to retrieve just that memory from that scope. And this is a way to create a sort of a knowledge base shared across the entire team.
Yeah, it is a great pattern to building a collaborative agents. And with that, it is time to wrap up.
And that's it from the Agent Factory. So hopefully you got some new ideas for your next project. But for now, I just want to thank you again, our great guest, Kimberly Milam.
Likewise, Evan, I really hope each of you learn from today's episode and feel inspired to build something cool.
That's right. And don't forget to share your question in our community or using the Agent Factory hashtag. So it's Ivan Nardini.
It's anyone.
Powering down.